Welcome to Lesson 4 of Module 5 on Extended Query Formulation with SQL. I'm going to start with an important question to check your understanding of the traditional set operators, the subject of this lesson. What is the difference between the join operator and the traditional set operators when matching rows? The first 3 lessons of Module 5 provided guidelines for query formulation and usage of the guidelines on more realistic problems involving joins and grouping. This lesson covers the usage of traditional set operators in the select statement to prepare for some usage of these operators in Course 3. The objectives in this lesson relate to the usage of the traditional set operators in the select statement. You should be able to explain the union compatibility requirement in the manner of matching rows for the traditional set operators. You should be able to write select statements using the union operator, the most important traditional set operator for query formulation. The union, intersection, and difference table operators are similar to the traditional set operators. The traditional set operators are used to determine all members of 2 sets for the union, common members of 2 sets for the intersection, and members unique to only one set for the difference, as depicted in these Venn diagrams. The traditional set operators assume that members of different sets can be compared to see if they are identical. When applying traditional set operators to tables, rows of a table are considered as members of a set. Compatibility is an important concept to apply the traditional set operators to tables. Union compatibility means that each table must have the same number of columns, and each corresponding column must have a compatible data type. Union compatibility can be confusing because it involves positional correspondence of the columns. That is, the first columns of the 2 tables must have compatible data types, the second columns must have compatible data types, and so on. In practice, compatible data types mean the corresponding columns have the same data type, except perhaps for the length specification. Both tables in an operation using a traditional set operator must be union compatible because all columns are compared. In contrast, the join operator involves a condition usually on a single column from each table. Thus, traditional set operators match on all columns compared to the join operator matching on a single column in most cases. Because few tables are union compatible, the traditional set operators are typically applied to a subset of the columns of each table. The union compatibility requirement reduces the usage of the traditional set operators. Compared to the join operator, the set operators are not widely used. However, the set operators have some specialized important uses. The union operator can be used to combine tables distributed over multiple locations. In Course 3, you will see examples of the union operator applied to tables containing summary data. The remainder of this lesson will present 3 simple examples of the union, intersection, and difference operators in the select statement. The traditional set operators are applied to query blocks, separate select statements combined to make a complete select statement using the set operators. Example 1 shows a select statement with the union operator. The union keyword applies to 2 query blocks. Each query block is a separate select statement with 4 columns. Each corresponding column is compatible. For example, fact number in the first query block is compatible to student number in the second query block. Fact first name in the first query block is compatible to student first name in the second query block, and so on. The columns are renamed so that the column names in the result are meaningful. Let's execute example 1 and examine the results. The result contains 16 rows with 5 columns, combining 6 rows in the faculty table to 11 rows in the student table. The union result contains 16 rows rather than 17 rows because 1 row is common to the student and faculty tables. Example 2 shows a select statement with the intersect operator. Just like the union operator, the intersect operator applies to two query blocks. The query blocks are identical in structure as in example 1. The intersect operator requires union compatibility, just like the union operator also. Note that example 2 only executes in Oracle, as MySQL does not support the intersect operator. Let's execute example 2 and examine the results. The result contains one row with 5 columns, combining 6 rows in the faculty table to 11 rows in the student table. The intersection result contains only the common row among the student and faculty tables. Example 3 shows a select statement with the minus operator. Just like the union operator, the minus operator applies to two query blocks. The query blocks are identical in structure as in example 1. The minus operator requires union compatibility, just like the union operator also. Note that example 3 only executes in Oracle, as MySQL does not support the minus operator. The SQL standard uses the except keyword instead of the minus keyword used in Oracle. Let's execute example 3 and examine the results. The result contains 5 rows with 5 columns, combining 6 rows in the faculty table with 11 rows in the student table. The minus result contains 5 rows, as one faculty row is common to the student table. Unlike the union and intersect operators, the minus operator is not symmetric. Thus, table 1 minus table 2 is not typically the same as table 2 minus table 1. Example 3 showed that faculty minus student produced 5 rows. In contrast, student minus faculty produces 10 rows, as the student table contains 11 rows, with 1 row in common with the faculty table. Let's execute example 3 with the query blocks reversed to demonstrate that minus is not symmetric. The revised statement shows students who are not faculty. The result contains 10 rows with 5 columns, combining 6 rows in the faculty table with 11 rows in the student table. The minus result contains 10 rows, as one student row is common to the faculty table. Let's wrap up Lesson 4 about using traditional set operators in select statements. The traditional set operators are specialized because they require union-compatible tables. Matching rows with the traditional set operator involves matching on all columns in each table, not just matching on a single column, as is done with the join operator. This lesson provided examples using the union, intersect, and minus keywords in the select statement. These keywords are applied to query blocks, separate select statements combined by a set operator to create a complete select statement. In Course 3, you will see some specialized uses of the union operator for tables containing summary data. The union operator has important usage for distributed and partitioned databases to combine identical tables in different locations or partitions.